Hi all internet, these are Java videos from Tech Skills for you, and this video is on stack overflow and stack memory of your JVM. Okay, so in the last video of my playlist we have seen a small program in the debug mode where all the methods are laid one upon the other, so they'll form like a stack here, right? So we are just trying to understand how they are executed in the memory. So let me tell you. Okay, so as soon as this program starts, when the program starts, as I said, a thread starts, right? A single flow starts. When a thread starts, what happens in the memory is, for each thread that gets started, right, there is a stack that's get created in the memory. This is the stack. So I'll call this as what? The stack. So let me increase the font of this to put in. Yes, looks good. So this is the stack area of your memory. So as soon as a thread starts, right, a stack gets created. So what is the first method that is getting called in the program? So it's main method. So what happens internally is, so when there is a method call, for each method call, the JVM allocates a stack frame for each method call. So what is this? This is the stack frame. I call this as what? Stack frame. So let me call this as what? Stack frame. So if there are 100 method calls, right? For each method call, you will have a stack frame getting created for each one. So this is the stack frame. So what is there in the stack frame? Okay, so this is created for what? This is created for the main method. This is created for main method. So this is the main method, and anything that's in the memory, right? Say for example, so when I'm running this program, the first method is what? Main. So what is there in the main? So main has a argument string, an empty string argument. So it won't take anything except this string literal memory. So when I click on this validate, right, see, it has two variables, first num and second num, and they take some values. So internally they utilize some memory of your system. So what happens, guys? So those variables memory, right, they take the memory of these frames actually. So internally, right, these frames are divided into some sections. It all depends on the JVM that we are using. In general, if I speak generically, right, so what happens is these frames are divided into some sections where some part of the memory is utilized for the variables and some part of the memory is utilized for what? The next method call. Say from here, which method am I calling? I am calling what? Validate, right? So it remembers which method it has called. Okay, so next, right after main, which method is called? Validate. So again there is a stack that's get created for what? This validate method. So this is again what? A stack frame that is getting created for what? The validate method. So similarly, this continues for all the methods actually. Okay, so this continues for all the methods. So from validate, what are we trying to do? We are trying to call add, and again we are trying to call what? Print some methods in sequence, right? So I'll try to add what? This is what? Sorry, this is what? This is the add method. And again this is what? This is your print sum. So by mistake I have just taken it as print result. Please apologize for that. This is the print sum method. Okay, so when this method call is happening, right, what happens? So all these will go into your stack one by one. Okay, all these are laid one upon the other in the stack. Okay, what is a stack? You know the stack algorithm, right? Last in and first out. So what is the last last method that is inside the stack? Print sum. That should go out first. How will happen? How it will happen? Okay, so when we are running this program, right, what is the last method that is getting called here? So we are in add here. Let me do F6. So this program is executed here, but let me again try to run this program, right? So what's happening here? It's going one after the other, and there is a stack that's got created in the memory. If you see here, there is a stack. Where are we now? We are in print sum method. As soon as the execution of this print sum is completed, what happens? See this area here, okay? There is a print sum method here, right? So I'm just doing an F6. So its execution is done. Now where are we? We are in add method. What's happening here? In the thread there is no print sum now, because the execution of this method is done, it's completed, and it's not at all required to it to be in the stack, so it's got removed. So in the memory what happens is this stack, right? Then in the stack what happens? This print sum method is executed and this gets removed. Okay, that gets removed from what? Memory. Okay, and next, where are we? We are in add method. So we are also done with the execution of add. So immediately if I do add, what happening? There is no add method here. So here also in the memory this gets removed. Okay, so continuously, right? If I do F6 like this, right, finally we are in where? We are in main method, and there is no other frame here. The same happens here. There is finally a main method here. So when I do F6 here, the program is done, and if you see here, right, the sample test, it's terminated and there is no thread here. So same as the program, there won't be any stack area. So this main method gets removed here, and finally, as there is no method call here, there is no need of this stack area, and finally this also gets removed, and the space is utilized or else been allocated for the next threads that start. Okay, say if I have 5 methods, sorry, if I start this program 5 times, so there are 5 threads that gets created, right? This program executes 5 times. So if I try to parallelly execute this program, okay, using some multi-thread logic, what happens is, for each thread, what happens for each thread, say for example if I have started the program 3 times, okay, what happens in the memory is each we get, I mean, JVM allocates a stack for each thread. So what is a thread then? Thread is nothing but a stack in the memory. So all the method calls that are in that flow, that are in the thread, are allocated here. Okay, so each method call is allocated here. Something. This is how the stack area of your memory is utilized. And one more thing to understand is, so when these frames are created, right? So we are just trying to overlap one on the other, right? And what we are trying to say? We are trying to say that this method, okay, this frame is divided, okay, into some areas, okay, into all the logic actually. So it depends on the JVM implementation. So what it tries to understand, what it tries to save, it will save the next method call. Say for example, if this is add, if this is in validate, okay, this is main, this is validate, and this is your add. So this validate method is calling what? Add method. And who called it? Main method called it. So it will remember who called it and who called it and who, to which method it is calling. So it will remember both. So with this we need to understand that the frames are not contiguous or else not continuous like this in the stack. They may be scattered, right? This area, as we are seeing in the pictorial representation, right, this frames may not be like this. So the frames can be created anywhere in the memory, but they are linked with the address that they save. So they save the method calls, right? So what is a method call? It will save the address of the method call.